So the title of this session is the Control and Design of Robotic Visuo-tactile Systems. And I try to think a bit about how I could group now the papers that we are going to hear, or the work we're going to hear about in this session. And so to me it was kind of bringing together tactile sensor signals and visual information. And obviously that is the whole workshop as well, but looking at it a bit more closely. So it is on the one hand vision-based tactile sensors, so sensor devices that are being used or which have a camera or similar integrated, and that is used then for tactile perception. And on the other hand, I see this this hybridized or this hybrid approach where colleagues fuse vision and tactile sensing in one way or another. So often is some vision input, could be also a depth camera on the one hand, and then tactile sensors being integrated there, being used to possibly confirm what's happening in the visual, from the visual input. And that obviously is then used towards controlling robotic systems to operate in their environments. So looking at the vision-based tactile sensors, I go back a bit in time and look at the work that we have done. And so we used a camera in that context already in 2012, as I actually realized. Not quite in the way it is done today, but so here we have a tactile finger, which is optics based. And so we have a deformable structure, which you can see here on the right-hand side, and the force is applied, and it changes the distance to the tips of these optic fibers that are being used here. And by doing so, we change the light intensity that is received back. And in this particular case, we use a camera. And so we have now multiple of these elements across our fingertip, 9 in this particular case. And we just feed the receiving fibers to the camera and can read out the force information that is arriving there. And it becomes just an imaging process that we have to carry out. Vision processing is being carried out. And in this case, we look at the area that is illuminated in this thresholded image. And that gives us an indication on the forces that are applied at these various tactiles along our fingertip. And we have then taken that idea also towards force measurements. So here we have a 3 degree of freedom force sensor. And again, a camera is used and is receiving signals from the receiving fibers. And you can see the spots here on the screen. You can see two very well. A third one is here, maybe not so easily visible. So 3 pieces of information coming in, telling us giving us the force information in along 3 axes. Very nicely expandable because you have a camera. You can connect multiple fibers there to this camera without any problem. So we could easily extend it, and it's also very low cost. But there are more obvious candidates now, and we will hear about the Tucktip sensor. And I have to speculate a bit because I haven't seen papers for all the presentations we are going to have here. But the Tucktip is, of course, a camera-based sensor. So here we have the camera sitting in the housing, observing a membrane or a skin, and measuring then the deformation, interpreting the signals, then to effectively draw conclusions to the forces that are being applied across the skin. And obviously I need to also mention gel sight in this context, and I hope we will hear more from Wen Zhen later in her session. And here again, and I mean, I would say the precursor of lots of work that has been happening, and I think it was 2014. I think it was the IROS conference in Chicago when I saw this work for the first time. I might be slightly wrong with the year and the place, but when I saw it, I was extremely impressed, and yeah, had also the desire to work in that area. And so just a quick overview of our Ftouch sensor. So here we are doing a very similar thing. We have a membrane that can deform, but different from other approaches. We have springs built in, which allow us to measure forces directly with the incorporated camera. And so the argument for that is that we can believe that we can measure forces more accurately, but also we don't need to have any pixels integrated with our skin. So as you can see here, we can see the USB tip without any, without being covered by any points, and at the same time can measure the forces and the directions. It's a 6-axis force torque sensor. I have to move forward and want to talk shortly about the hybridized approach. So here, the way I see it, the approach taken is to have a camera or a depth sensor that observes the environment, gets some information, and that is then updated or further improved by tactile information, for example, from a fingertip here. Again, I speculate a bit on that work. I hope we will hear more from Kyung Lee later. And their similar work is also will be presented by a team, combined team from Naples and from IIT in Genova. And so again, a camera system is used to get information about the environment, and then tactile information is incorporated to give more information about the objects that are being handled. Again, very similar work by colleagues here from Queen Mary, and Francesca will hopefully talk about it later. We use a camera system to get information about the environment, do some processing on that, and that gives us an idea on where potential cracks are in this particular case, and these are further investigated then by a force sensor. Finally, that is also related to work that we are doing, but also colleagues from Japan involved here, giving a slight twist. So here we have a tactile sensor that gives us information, distributed information, which can interpret it as an image, and which can be then further processed using image processing techniques. And I'll come to the end now, but before I go, I just want to remind everyone, I cannot help it, that in 2023 ICRA will come to London.